Today's transformation is on rotations. So rotations is when you rotate a figure either counterclockwise or clockwise around a certain point. So you can see in this model here, we have point Q, which is the point of rotation, and you can see that the pre-image is rotating counterclockwise. It's moving this direction around that point. So a rotation is a transformation that turns a figure about a fixed point. The fixed point is called the center of rotation. Rays drawn from the center of rotation to a point and its image from an angle are called the angle of rotation. You can see that up here. This is the angle of rotation. The angle is formed by two rays. That goes back to Unit 1, so some vocab from Unit 1. All right, question for everyone. Does a rotation preserve distance and angle measure, otherwise known as our vocab word from the first lesson of this unit, rigid motion? And yes, it does. So a rotation is a rigid motion. It keeps the size and the shape the same. It just moves the figure about a certain point. So there's some rules that we need to follow. And one of the biggest rules, or one of the biggest topics of this entire lesson, is that all rotations will be counterclockwise unless stated otherwise. So every rotation moves counterclockwise without anything else being said. The only time it doesn't move counterclockwise is if you see a direction somewhere that tells you to move it clockwise. And you'll see when we start going through examples what I mean by that. So starting with a 90-degree rotation. To rotate a point 90 degrees counterclockwise about the origin, you multiply the y-coordinate by -1, and then you interchange the x and y coordinates. So the rule that you have to know, the rule that you have to follow is x comma y, your pre-image point, maps onto -y comma x. So flip the points, make your y-coordinate negative. You can see in our model on this side that point P is your pre-image. It is moving counterclockwise to its image. Think of the second hand on a clock. Counterclockwise is the opposite direction that the second hand on a clock rotates. So if you have a clock nearby, you can look at that and determine which way is counterclockwise. A 180-degree rotation counterclockwise is when you multiply the x and y coordinates by -1, and that is it. You do not interchange any points. You just make each one of them negative. So x comma y for the pre-image point maps onto a -x and a -y value. If you look at the model, your pre-image point is in quadrant 1. It rotates counterclockwise to its image point. And take a look at the ordered pair. You start off with +5, +2. You end with -5, -2. And then we have a 270-degree rotation counterclockwise. To rotate a point, oops, that's a typo. Everyone needs to fix this. To rotate a point 270 degrees counterclockwise about the origin, you multiply the x coordinate by -1, and then you interchange the x and y coordinates. The rule is stated x comma y maps onto y comma -x. In the model, your pre-image is in quadrant 1. It rotates counterclockwise 270 degrees to its image point. And look at the ordered pair. We start off with 5, 2. We switch the points and make the original x coordinate negative to give us 2, -5. Now suppose we were asked to perform clockwise rotations, and we want to know what rule to use. Well, these rules are the same, but they're applied slightly different. So a 90-degree clockwise rotation, if you start at the original point, I'm going to start right here where we were just at. If we start at the original point and move 90 degrees clockwise, it's going to land in the same location as 270 degrees counterclockwise. So not only is this rule going to apply to 270-degree counterclockwise rotations, it's going to apply to 90-degree clockwise. So you have the same rule used for two different applications. If you move a figure 180 degrees counterclockwise, that is the same exact thing as moving it 180 degrees clockwise, because that forms 360 degrees. So the 180-degree counterclockwise rotation rule applies to two applications as well. And lastly, I am assuming you could figure out what this one goes to, but if you are doing a 90-degree counterclockwise rotation, that is the same thing as a 270-degree clockwise rotation. So once again, this one rule applies to two applications. Recall that all of the applications, if you add up the degrees, such as 90 plus 270, that's 360. 180 plus 180 is 360, and 270 plus 90 is 360. Okay, moving right on to our examples. So we are given a figure and we're asked to rotate it about the origin. The origin is this point here. Okay, focus on the directions. It says rotate PQRS 270 degrees about the origin. That means we are rotating 270 degrees counterclockwise. It's always assumed to be counterclockwise, unless you're told otherwise. So the rule for 270-degree counterclockwise, if you look back on the first page, is x comma y maps onto y comma -x. So I'm actually going to make a table of values for this just so I don't mess up any of the original points. And I'm going to apply my transformation rule. So let's start with point P. Point P is located at 1, 1 on the coordinate plane. When we apply the transformation rule, we are going to make the original x coordinate negative, and we interchange the points. So 1, -1. I'm actually going to plot that as I do them. So 1, -1 will be located here. Point Q is at 3, 3. And if we apply the transformation rule, Q prime is going to be at 3 comma negative 3. Point R is at 4 comma 1. R prime, make the x coordinate negative, and then switch locations, is going to be at 1, negative 4. And lastly, S is at 3, 0. Make your x coordinate negative and switch their locations. 0 comma negative 3 is the location for S prime. I'm going to connect these points for my image or my final answer. And this figure here is my final graph. I'm actually going to highlight the final coordinates over here, just so we know that's where they are. We rotated this figure 270 degrees counterclockwise. Okay, for number 2, if you want to try this by yourself, then please press pause and try to complete this one on your own. If you want to just watch as I go through it, you can do that. I'm not going to explain it. I think it's very repetitive explaining, so you can just watch as I write on the screen. Or, like I said, you can try it on your own by pressing pause. So at the bottom of this page, there's a box that says, what if the figure is rotating clockwise? And we did already talk about this. So we talked about it when we first went over the rules. I did rewrite them here for you. So you can see I wrote the counterclockwise rule and then what clockwise rule it corresponds to. So for example, in this first column, the 90-degree counterclockwise rule is the same thing as the 270 degrees clockwise rule. So if you want to take a moment and rewrite the rules with this table, please go ahead and do so. The next example that we do is going to be a clockwise rotation. And actually, while you're writing this, I'm just going to look at the directions of the next example. And I'm just going to highlight how in these directions, you can see that it specifically says clockwise. Okay, the other examples have not specifically indicated a direction, so it's assumed to be counterclockwise, whereas this one is saying clockwise, so that means you have to rotate it 270 degrees clockwise. Also, while we're talking about this, because we're rotating 270 degrees clockwise, that is the same rule as 90 degrees counterclockwise. So we'll be using that first rule that I just circled in my table above. So for number 3, we have our original figure that has ordered pairs F at 2, 1, G at 6, 1, H at 6, negative 3, and J at 1, negative 3. This is called our pre-image. I'm going to make a table for my rotation, which says that I have x comma y mapping onto negative y comma x. I'm going to apply that transformation to each one of these points, and I'm going to graph the image. So starting with point F is at 2 comma 1. The transformation rule says that I'm making the y coordinate negative, and then I switch the x and y location. So f prime is going to be located at negative 1 comma 2. Point G is at 6 comma 1. G prime will be at negative 1 comma 6. H is at 6, negative 3. H prime, when you flip the coordinates and make your original y coordinate negative, it becomes 3 comma 6. And the last point, point J, is located at 1 comma negative 3. J prime will be at 3 comma 1. When I connect to these points for my final answer, this figure here is the final image. So our pre-image is the image sketched with a black marker, and the pre-image is a black marker, the image is the blue marker. I will highlight the final coordinates. And just as a reminder, this is a clockwise rotation because it specifically tells us to move clockwise. Okay, for the next set of examples on the notes, this is when you are rotating a shape not about the origin, and this gets a bit more challenging. I did type out the rules for you. However, I'm not going to spend time reading through them because I explain them as I go through the example, and I think you will understand them better as I do the example while explaining. However, these are typed out for you so that you can reference back to your note sheet and see what you're supposed to do. So if we move right down to the note sheet, to the examples, we are going to be rotating a figure about a given point. We need to completely read the directions here and take out what's important. This says what is the image of point J. I'm just giving you one single point for this first example, which is at 3 comma 4, after a rotation of 90 degrees about point P, which is at 1 comma 1. So a 90-degree rotation about point P. Also, remember, it does not say which direction, so when it doesn't say, you know you are moving counterclockwise. I'm going to take a moment. I'm going to indicate that point P is here, and I'm going to draw well, first let's plot the point. Sorry, I forgot I didn't do that. So point J is at 3 comma 4. Okay, now back to what I was saying. I'm going to take a moment and I'm going to draw a new X and Y axis. I'm going to do them in orange just so I can clearly see where they are. I like to do this every time so I don't mix up any points. Now, you might just want to watch what I do and then come back, press pause, and fill in your note sheet. But what I like to do is I like to keep myself extremely organized, so I set up a table of values and I end up with 4 columns. So my 4 columns are going to be the original coordinates. And as I write these out, I'm going to fill them in. So my original coordinates of point J are just like we started with. They are at 3, 4. The next column I am going to put in quotes because there's really no other way to explain this, but we're going to put fake coordinates. And then I'm going to write fake coordinates based on fake center. Now, what I mean by that, here's your fake center. So if we assume that this is 0, 0, where's point J if this is 0, 0? Well, point J would be over 1, 2, up 1, 2, 3. So based on our fake coordinates, J is at 2, 3. For the next column, I am going to do the fake rotation or fake coordinates rotation. So if we're moving 90 degrees counterclockwise, our rule tells us that x comma y for the original coordinates is going to map onto negative y comma x. So I am using my fake coordinates and I'm applying this transformation rule, which tells me that j prime is going to be at negative 3 comma 2. Again, I'm using my fake coordinates for these two columns. I applied the transformation rule to my fake coordinates. So now I come back over to the graph and using my fake center of origin, so what I labeled as the fake one, I'm going to plot a point at negative 3 comma 2. So I go over 1, 2, 3 for negative 3, up 2. That is my new point. That's point J prime. Okay, forget about the original x-axis for now. Just for those two columns of my table, you're forgetting about that and you're using, you're using this center as your center. Now for the last column in my table, sorry, just making more room here. I'm going to label the last column as the final, and then they're going to be the final real coordinates. So I'm going to erase my fake center. And now I'm going to go back to my original center of origin, and I'm going to count over to where that point is that we just plotted. And that point is at negative 2, positive 3. Negative 2, positive 3 is my final answer. That's what I'm looking for. So you need to be able to locate where that point is, and you need to be able to identify the actual ordered pair of it, which again is going to be back to the real coordinates. So that last column in this table, that's the most important column because that's the actual answer. The next example is a shape. So to save us some time, I'm going to copy the table that I just made with all the writing in it. Okay, so number 2 tells us that we have triangle XYZ Triangle XYZ has vertices at 0, -1 for X, at 3, 1 for Y, and at 1, 5 for Z. Here is my original or my pre-image figure. We are told to graph XYZ and its image of 90 degrees about point P, which is at -1, 1 this time. So a 90-degree rotation tells us that we have X, Y mapping onto -Y, X. And notice where I lined those up in my table. So in my table, I lined up my rotation rule. That's what this is. So my rotation rule is lined up with the fake coordinates and the fake rotation coordinates. I do the same exact thing for every problem. Next, I'm going to create my fake X and Y axis, which is when I draw my new axes through point P. I'm going to highlight point P because it's important to know where the center is. And we're using my highlighted orange X and Y axis as our new center. Okay, in the first column, we have our original coordinates. I'm going to go one coordinate at a time right through this. Starting with coordinate X, or point X, at 0, -1. If I go over to my new origin, X is at 1, -2. When I apply my transformation rule, X prime is at 2, 1. When I plot X prime based on my fake center of origin, 2, 1 is located here. If I go back to the real center, which is, actually, you know what? Let's save that for after. I can erase all of my extra notes and we can clearly see where they are. So let's move on to point Y, which is at 3, 1. On my fake axis, Y is actually at 1, 2, 4, 0. Y prime, when you apply the rule, is at 0, 4. So when I plot that on my coordinate plane, it is located right there. And lastly, point Z originally is at 1, 5. Based on my new coordinate plane, or new center, it's at 2, 4. When I apply the rule, Z prime is at -4, 2. Okay, now I'm going to erase all of my fake axes, so my X and Y axis. Let's get rid of all that so it's out of our way. I can connect my points because I didn't do that yet. So I can use my nice clean slate without all that extra work on there to connect my triangle or connect my points. And now I can see my final coordinates. For point X, based on the original center of origin, X prime is at 2, 1. I wrote that backwards. Oh, my bad. 1, 2. Point Y is at -1, 5. And point Z is at -5, 3. These are your final coordinates. This is your final answer. Okay, please press pause on your video and try to complete the last question, which is an on your own section or on your own question by yourself. Come back to the video and you will see my work done out. Please let me know if you have any questions and take your time with these because, especially this last section on the note sheet, it is quite involved and it's more difficult than previous things we've done. So go slow and take your time. Do not rush these examples.